Now let's consider more logarithmic properties. So one thing we want to note is the one-to-one property may not always be applicable. So for instance, let's suppose we had an equation like so. If we have log base 3 of 2x plus 5 plus log base 3 of 3x equal to 4, well, you'll notice that when we have the one-to-one property, we have usually one log on one side and a log on the other side. Well, in this case, we have two logs over here on the left-hand side and no log over here on the right side. So the one-to-one property would not be able to apply in this case. So that means we would need to combine the two logs that we have over here on the left side. And so we have three new rules that we can apply in order to combine logs. So first we have what's called the product rule. The product rule just says if I have log base b of two functions being multiplied together, m times n, then I can rewrite that as log base b of my first function m plus log base b of my second function n. So if I'm doing the product rule, means I am multiplying two functions together, then I can expand that into two logs by using addition. So that's the product rule. So just remember, product goes with plus. Then if I have the quotient rule, that means I'm now dividing two functions. So if I have log base b of some function m divided by n, then I can rewrite that as log base b of my top function m, then minus log base b of my bottom function n. So if I am using the quotient rule, if I am dividing, then I separate with a minus. So just remember, with quotient, you want to use a minus, okay? So if I'm dividing, that corresponds to a minus. Then finally, I have the power rule. Power rule just says I have log base b of some function raised to the nth power, okay? N is just some number. So the way I can rewrite that is I bring that power to the front. So here I have that n in the front now being multiplied by my log base b of my function m. So that is the power rule. So just remember, I bring that power to the front. So now let's take a look at this example. We want to use those logarithmic properties to evaluate the following expressions. All right. So let's look at this first one here. We have log base 2 of 96 minus log base 2 of 3. So you'll notice we have the same base 2 for both logs, and we have this minus in the middle. All right, so if we want to apply one of those logarithmic properties, then we remember with the minus, that corresponds to division. So therefore, we're going to apply the quotient rule. So we're going to rewrite this applying that quotient rule. So let's remind ourselves what that quotient rule said. So if I have log of any base b of some function divided by another function, then I can rewrite it with log base b of my top function minus log base b of my bottom function. Well, if you notice, we have exactly what we have over here on the right-hand side of that equation. So therefore, we can rewrite it as what we have over here on the left side. So we have the same base for both logs, so therefore we know we can apply this rule. And we're just going to rewrite it as log of base 2 of my m, in this case that's my 96, over my n, in that case n is 3. So now that we have rewritten it, we have log base 2 of 96 over 3. Now let's see if we can simplify this. Let's divide out 96 over 3. And so that's just going to be equal to log base 2 of 32. So now we're going to set this equal to y so that we can evaluate this expression. So now if you remember, we now can rewrite this in the equivalent exponential form. So if you remember that circular pattern, we can take the base, raise it to what we have over there on the right-hand side, and set it equal to 32. So now we have 2 raised to the y is equal to 32. So now we want to eventually try to solve for y, okay? Whatever we get for y, that's going to be the value of this expression. So let's see if we can try to get equal bases. We have a base 2 over on this side, and over here we technically have a base of 32. So let's see if we can rewrite this base of 32 so that it's 2 to some number. Usually we want to try to go with the smaller base of the two. If we can get them to have a common base, that's the goal that we want to try and get. So let's rewrite 32 as 2 to some power. And so 32 is the same as 2 to the 5th power. Where now you can see we have the same base on both sides. So anytime that is the case, then we must say that the exponents of those bases must be equivalent. So therefore y must equal 5. So therefore, if y is equal to 5, then we have just evaluated this expression because we had rewritten the expression and set it equal to y, solve for y, so therefore this expression itself must be equal to 5. So that's how we're able to apply that quotient rule, which is a logarithmic property, to evaluate this expression. Well, now let's take a look at this second example. We have log of 250 plus log of 4. Well, first you would notice neither one have a base here. So whenever the base isn't given, we know that it has an understood base 10. So therefore we can rewrite it with the understood base given. Now we see that we have two logs both with the same base. Let's see if we can apply one of those rules. Well, here we have that plus in the middle. So remember, with the plus correspond to the product. So let's see if we can remind ourselves of that rule. Well, the product rule just says if I have two logs added together, they both have the same base, then I can rewrite it as log base b of those two things being multiplied together, those two functions m and n. Well, in this case, our m is 250 and our n is 40, so we can rewrite it with the 250 being multiplied by the 4. So now if we multiply 250 times 4, we'll get 1,000. And so now we want to evaluate this log base 10 of 1,000. Well, we can set this equal to y, and then remember we can use that circular motion pattern. And we do that to get the equivalent exponential form. And so now we want to see if we can get the same base on both sides here. So here I have a base of 10, here I technically have a base of 1,000, but I can rewrite 1,000 as 10 to some number. And of course 10 to the 3rd power is the same as 1,000. So now that I have the same base on both sides, then that means my exponents must be equivalent. So therefore, y must be equal to 3. So remember, we had set y equal to the equivalent expression of what we had here. So therefore, this expression must be equal to 3. So that's how we're able to apply those rules, those logarithmic rules, quotient rule, and product rule to help us evaluate logarithmic expressions.